this is our next question, in which we are given with find the equation of line through a point -2, -7, which is having an intercept of length 3 in between the two parallel lines 4x plus 3y equals 12 and 4x plus 3y equals 9. Now this is a very important question because it teaches us a new concept, the concept of parametric. Now as usual, we first draw the two lines. Let us say this is 4x plus 3y equals 12. Let us say this L1, and this is L2 as 4x plus 3y equals 3, and this is a variable line. Let us call this L3, which passes through -2, -7. Now let us say the distance of this point to this line is R1, and let us say this distance is R2. So we know that R2 minus R1 is given equal to the intercept between the two lines, which is equal to 3. This is our first equation. Now the parametric says that any line which passes through -2, -7, we can write it as x minus -2 upon cos theta equals y minus the y coordinate, which is -7 here, upon sin theta equals r, where r is any general distance from the point, where tan theta is equal to the slope of the line. So we can write this as x plus 2 upon cos theta equals y plus 7 upon sin theta equals r. Now taking r as r1, we can easily get the coordinates of point A. The coordinates of point A will be r1 cos theta -2, r1 sin theta -7. Now students can do this question without using the parametric concept also, but that will be a bit tedious and a bit longer. The coordinates of point B can similarly be find out. We can find it by putting r as r2. So we can get it r2 cos theta -2, r2 sin theta -7. Now we know that the point A satisfies the line L2, which is 4x plus 3y equals 3. So putting the coordinates of A in the line L2, we get 4 times r1 cos theta -2 plus 3 times r1 sin theta -7 equals 3, which gives us the value of r1 as 32 upon 4 cos theta plus 3 sin theta. Similarly, on putting the coordinates of r2 in the line L1, we get 4 times r2 cos theta -2 plus 3 times r2 sin theta -7 equals 12. So we get the value of r2 as 41 upon 4 cos theta plus 3 sin theta. Now we know r1 and r2 both in terms of cos theta and sin theta. Now we know both r2 and r1 in terms of cos theta sin theta, and we can put them in the equation which we know r2 minus r1 is equal to intercept between the two parallel lines, which is equal to 3. So r2 minus r1 we can clearly see it is equal to 9 upon 4 cos theta plus 3 sin theta, which is equal to 3, which gives us 3 times 1 minus sin theta equals 4 cos theta. Now we can square both the sides to get 9 times 1 minus sin theta whole square as 16 cos square theta, and we can write cos square theta as 1 minus sin square theta, which gives us 1 minus sin theta into 1 plus sin theta. On cancelling one of the factor, we can write sin theta equals 1, which gives cos theta equals 0. So our line will become x plus 2 by cos theta equals y plus 7 by sin theta, which gives us x plus 2 equals 0. This is the first equation of the line. Similarly, we can get another equation, as we have one more equation in sin theta cos theta, which is 9 minus 9 sin theta equals 16 plus 16 sin theta, which gives us 25 sin theta equals minus 7, sin theta equals minus 7 by 25, and cos theta equals 24 by 25. So we can write x plus 2 upon cos theta, which is 24 by 25, equals y plus 7 upon sin theta, which is minus 7 upon 25. On cancelling this 25 factor, we get minus 7x minus 14 equals 24y plus 168, which gives us 7x plus 24y plus 182 equals 0. So this can be our second equation of the line. So the two equations of line passing through minus 2 comma minus 7 and having an intercept of length 3 between the two given parallel lines is x plus 2 equals 0 or 7x plus 24y plus 182 equals 0.